Welcome to part 3 of my lectures about experimental designs. Um, in this last lecture, I'm going to talk to you about true experimental designs. Remember, in pre-experimental designs, there was no random selection, no random assignment, and there wasn't there weren't groups to compare to, or there weren't pre and post to compare to. In quasi-experimental, that's where you get the pre and the post and groups to compare, but there's still no random selection, random assignment. In experimental designs, you're truly going to see random selection, random assignment, and groups to compare to. So I would suggest that you do the same thing again that you did in the last lecture if you found that helpful. Study number 6. A group of 300 students, we pull in these 300 students who are randomly selected from the 11th graders in an urban high school. So there's your random selection. Then each student of that 300 was randomly assigned to a type of SAT prep study, including a control group which did not study. Ha ha. Obviously, this isn't ethical and we wouldn't do it. Then the SAT scores for the students were analyzed. So what's the hypothesis? Can you write out the notation? And what type is it? So you may want to pause now. Well, the hypothesis would be something like students using different types of study will perform differently on the SAT exam. So when we look at the notation, note that R, there was random selection and random assignment to the group. There's probably be 2 R's there, but I've never really seen that. So there's random assignment, then you've got group A. They got intervention 1, maybe the Princeton Review, and then we looked at the outcomes for them. The next group was also randomly assigned, had been randomly assigned. That was the second intervention. The third group and the fourth group is your control group. This is true experimental design. This is called a randomized post-test only with multiple treatment groups. And yes, you will see that written out in research articles. Now, there are so many permutations and varieties of this that I am not going to lead you through any more of these studies. But let me talk to you about 4 and just using the notation, and let's make sure that you're on the right track. In the top left quadrant there, you'd have random assignment to either group A or B. Then there'd be an intervention for group A, and you'd look at the outcomes for both groups and compare them to see if there's a difference in the scores on the outcome. Moving over to the right, in the top right quadrant, once again, you've got random assignment to groups. So group A and group B take some kind of pretest. So you have some kind of measure at the beginning of where these groups are. Then group A has an intervention, and you look at the outcomes for both groups. This is the simplest true some of the simplest true experimental designs. And you can see why it's so difficult to do these in classrooms and schools and with children. In the bottom left quadrant, once again, you've got random assignment. Actually, that's the same example as up in the top right. Don't worry about it. Over to the bottom right, though, we've randomly assigned our subjects to 3 different groups. We did a pretest. Then there was intervention 1. You will sometimes see it noted this way where there's intervention 1, 2, and 3. And I've grayed in the third treatment because sometimes they label it as X3 and it's really the control group. So it could just be empty there, and then you would know that's your control group that's getting no treatment. And then at the end, we gather our observation for all of them. So you can see that in all of these cases with experimental design, once again, I know I sound like I'm harping on this, random assignment, an intervention that the researcher decides goes, to one group or the other. They're manipulating that intervention, and then there's some kind of outcome that you're looking for. So, the value of true experimental designs is that our groups are usually equivalent. They're usually statistically equivalent. And that comes because we randomly selected subjects from the population. So that should be a good variety from among the population. Then we randomly assign them to the groups. So each group, that's one of the properties of random assignment, is that the groups become equivalent. We also have high control over the extraneous variables. In other words, there's often different levels of the treatment that let us control for, well, how much is enough, how much is not. And once again, this is helped by that random selection, random assignment. Because when I took these 300 kids out of the high school, when I randomly selected them and then randomly assigned them to groups, say there's something great happens at the high school that week, that extraneous variable is not going to matter, because I've got kids from across the high school representing the high school, and I've got all kinds of their different reactions to that event should be represented in my groups. So I can't emphasize enough that in experimental design, that's the true value of it. You've got random selection, random assignment, so that lets you control for all these extraneous variables that might come in, because you've got such a variety in your groups. With true experimental designs, you can have really high confidence in the cause and effect. You can say with confidence, once you do the analysis, if it comes out that there is an effect, that this variable that you manipulated actually had this outcome. It caused this outcome very clearly. So just to kind of review, pre-experimental groups or designs. There's no comparison groups in pre-experimental designs, and there's no randomness. In quasi-experimental, that's where you start to see the comparison groups, but there's still usually no random selection, but there may be random selection of the groups. And in true experimental, you'll find comparison groups, and you'll have random selection and random assignment. And you can see why most of what's called experimental research in the educational world is quasi. Now, I'm going to talk to you a little bit about factorial designs, because this will come up in a lot of the research that you read. Factorial designs is referring to the number of independent variables that you've got in your design. So in this example, perhaps I've got a math intervention, and that's what I'm going to manipulate. I'm going to have a control group, and this group's going to get the math intervention, and this one isn't. And then I've got my dependent variable, which would be their math scores, obviously. So this is a single factor design. It has one independent variable. Now compare that if in my research design, I want to have a group that has the intervention and a group that doesn't. So I'm going to manipulate that independent variable. But I'm also going to look and see what gender has to do. Do the boys do better or the girls do better in this situation? And then my outcome is the dependent variable. This is called a factorial design because it's got more than one independent variable in it. You always have to have one that you're manipulating, but the other may be simply there. It may be an organismic one, such as gender, where we're not changing anything there. We're just recording it and looking at the data because of it. Now there's another variation on this too, where I could have an independent variable, which is studying time, the time of study. But in this case, I've got 3 levels of that independent study. I've got a group that's going to be randomly selected and randomly assigned to study 1 hour a week. I've got a group that's going to study for 2 hours a week, and I've got a group that's going to study for 3 hours a week. So and then my dependent variable is the math scores. And then I could have a research design, a factorial design, where there are 3 really clear independent variables. One of them I'm going to manipulate, the math intervention. And then the other one, another one, gender, obviously that one's not going to be manipulated. And then teacher experience. So I may look at those who have been teaching for up to 5 years, 6 to 10 years, and so on, and turn that into an independent variable. Obviously, I'm not going to manipulate that. I'm not going to tell a teacher, oh, all of a sudden you have 3 years of experience. But this is a factorial design. Now, the top one here is what's called a 2x2 factorial design. And what that means is that my first independent variable, the intervention, has 2 conditions, either yes or no. They're going to get it or they're not. And my second independent variable, which is gender, whether they're a boy or a girl, has 2 conditions. So this is a 2x2 factorial design. Now look at the bottom example. My first independent variable, which is study time, has 3 conditions or 3 levels. It has 1, 2, or 3 hours. And the second independent variable, which is gender, has 2 conditions, boy or girl. So in that case, this is called a 3x2 factorial design. 3 means the first independent variable had 3 conditions or 3 levels. And the by 2 means that the second independent variable had 2 conditions. So you will see this often in research too. Let me show you what they're actually referring to when they do this. In the top example that I just went through, where it's a 2x2 factorial design, what they mean is that if they make cells, they turn this into a grid. Down the left-hand side, I've got the boys, which I'm designating as a B, and the girls, which are as G. Across the top, I've got intervention number 1, and I've got no intervention, which I'm coding as a number 2. That means in the top left cell, I'm going to record the scores, the mean of the scores for the boys who got the intervention. Moving to the right, I'm going to record the mean for the boys who did not get the intervention. Down to the bottom left, I'm going to record the mean on the scores for the girls who got the intervention. And on the right, in the bottom, I'm going to record the scores for the girls who did not get the intervention. So I have 4 different mean scores that I'm looking at for these different groups. So I've taken these randomly assigned children, and I've randomly assigned them to either an intervention or not. But then inside those groups, I've pulled out the scores for whether they are boys or whether they are girls, so that I have 4 distinct mean scores to compare. What I'm trying to do is see if there's a difference with the intervention, if it depends on whether the subject is a boy or a girl. If gender has an effect on the effect of that intervention. I'm looking for an interaction between intervention and gender. Let me show you another example. And hang with me. This can be very confusing, but you're going to run across it, so you need to understand it. In this one, I've got 3 levels of my IV number 1, my independent variable number 1, and I've got 2 conditions, boy or girl. So this is a 3x2 factorial design. 3 times 2 is 6. That means I'm going to have 6 cells this time. I'm going to have 6 different scores or mean scores that I can compare. So across the top, I put my independent variable number 1. There's 3 conditions: 1 hour, 2 hours, and 3 hours. Down the left, I put the group for the boys and the group for the girls. Top left, I'm going to write down the mean score for the boys who studied for 1 hour. Moving to the right, I'm going to put the mean score for the boys who studied for 2 hours. And moving to the left, the mean score for the boys who studied for 3 hours. And then across the bottom, I'm going to do that for the girls, whether they studied 1 hour, 2 hour, or 3. In other words, I'm taking the mean score on the outcome and I'm actually breaking it up into 6 different groups so that I can compare and see if there's an interaction between gender and study time in their math scores. Now, when you look at factorial designs, what you end up with is really little tiny mini experiments. So I could have said, I want to look at I could have done an experiment to just look at the math intervention on math scores. That would be a single factorial design. I could have done a little mini experiment that was looking at the effect of gender on math scores. I could have done another experiment where I looked at teacher experience and that effect on math scores. But when I do all 3 together, I end up with some statistical power in doing that, and I don't lose power because I'm analyzing them all together, and that becomes statistically more powerful. And we'll talk about that a little bit in the inferential statistics section. One of the keys to understanding this is when you end up with an interaction and a factorial design, you can say for the main effect, you're saying regardless of gender or teacher experience, see how that's blue? I've got an effect of the math intervention. Now, if you look across the red line, that's the main effect for gender. Regardless of intervention or teacher experience, I've got an effect for gender. And then in the green one, regardless of either the intervention or the gender, just ignoring those, I've got an effect of teacher experience. And so those are called the main effects. And they're like 3 little mini experiments. The really cool thing about factorial designs is that you can start to see an interaction. That's what's cool. It may be interesting to know that there's a main effect for this intervention. And it may be cool to know that there's an effect for gender on the outcome of math scores. But what I really truly want to know is if there's an interaction between gender and the intervention. In other words, does the effect of the intervention of my independent variable depend on whether my subjects are boys or girls? And then I can start to say the effects of the math intervention were stronger for boys than for girls. Usually, this is represented with a graph. That's the easiest way to visually look at it. And when you look at a graph like this, you look over here at the starting point. And the red line is girls, the blue line is boys. So they roughly, if there was no math intervention, the girls and the boys scored about the same on the outcome. Now look over to the right where there was for the math intervention. The boys scored a mean of 42 and the girls scored a mean of 23. Is that what that is? Both groups benefited from the math intervention. But there was an interaction and the boys then benefited much more than the girls did. And then what we want to do with statistics is see if there's a statistical difference in the way that they scored. So there is an interaction happening here. Now, if there's no interaction at all, then there's just main effects. And you can see in this one that there's it's stopping you from seeing that on the right hand side is where the intervention was. I apologize for that. But you can see right away there's an effect for gender, isn't there? Boys are scoring much higher than girls. We don't know if it's statistically significant or not, but they are scoring higher. And the same thing happened when there was a math intervention. They score higher, the group that had the math intervention. So there's not an interaction between the intervention that's happening and the gender in this case. The boys were scoring higher without it, and the boys are scoring higher with it. The girls are both groups benefited from it, but the benefit doesn't depend on whether they are a boy or a girl. I know that's been confusing, but I go back and listen to it again. Look at it in your textbook. Factorial designs are the bread and butter of experimental research and quasi-experimental research. So you really need to kind of get a conceptual handle on that. When you're critiquing experimental designs, you're reading and you're consuming this, and you've got to make some judgments about them. Keep in mind that the purpose of experimental designs is to test a causal hypothesis. Your hypothesis is saying, because of this, this will happen. Or this will happen better with this group than the other group. You want cause and effect. You need to look and see that there's an explanation of which independent variable was manipulated. It's not true experimental design if there's not a variable manipulated or changed. You need to look at whether the researcher identifies the specific research design. You should see something like it was a non-equivalent groups, pre-test, post-test. And then you know that you could, there was no random assignment because they were non-equivalent groups, and you could think through the notation of that. The researcher should always let you know what extraneous variables were controlled for and how much control there was. Remember that there's that tension between internal and external validity depending on how much control of the variables there is. The intervention should always be described in detail, and the researcher should show that an effort was made to judge or evaluate or record what the fidelity to that intervention was. If they say they did an intervention and there's nothing in there about how they controlled for fidelity, then I would question that quite a bit. You also need to look at the number of participants for the number of cells, if there is a factorial design going on there. Because if there are too few subjects in each cell, then you can't take confidence in the results that come from that. So you need to be looking for that. Now, last of all, very quickly, I want to talk you through single subject designs because you may run across those as you read research articles. This is when there's an experimental treatment done for one subject. This is often done for special needs students or exceptional children. It is sometimes done in counseling and different counseling techniques. We call it single subject, but you can, up to 3 people, you will sometimes see the experimental treatment done for 3 people. It is most valuable when there are repeated measures, when it becomes an interrupted time series, when there's repeated measurement before, lots of ways that you're testing these kids or getting a handle on what the behavior or knowledge or skill is, and then the treatment, and then afterwards you test them again and again and again, because you want especially with exceptional children and in counseling research, we want to look at a group of pre-scores and a group of post-scores so that we can triangulate and really be certain that we're measuring what we're measuring, because we only have one subject or maybe just a handful of subjects. This kind of statistical analysis is not very common because it requires some really sophisticated statistical analyses, and the person has to be well trained in understanding these. So the concern there is when you see that someone has done an intervention for one person and then given an outcome, you need to take that with a huge grain of salt. Use a whole salt shaker on that one. Unless the person is specifically referring to a single subject design and can explain the analyses that were done on that. When you do read those studies, you need to look for a target behavior that's operationally defined. So when we're looking at this outcome, what are we really trying to see? There have to be really reliable measures of that. It's also important that there are sufficient measurements, enough before and enough afterwards, and that there's enough time for this intervention. You would never accept the results, please, for a design where this person was tested or evidence was gathered, and then an hour later there was an intervention, and an hour later you started testing them again. When you're looking at single subject designs, you're looking for stability and a pattern over time. And very often we come back and we post-test 3 months later or 6 months later to see if there was a lasting power for that intervention. Very powerful research when we can do that. Of course, you want to look for the description of the subjects, the procedures that were used, and the context is critically important to understand when you're looking at only one subject. You cannot do single subject designs with more than one independent variable at a time. And then always, when you're looking at single subject designs, think back to my lecture about practical significance. There was a change there perhaps, and it was documented. But is there a practical significance to that change? Is it worth reporting? Well, that in a nutshell is experimental designs. This is a chapter that you need to go through very carefully and highlight or flag or practice with whatever works for you so that you can understand and recognize these different research designs. Be sure that you understand the difference between pre, quasi, and true experimental, and that you can understand what the notation refers to in this.